Hey everybody, a while back I made a video on the derivatives of the trig functions as well as the derivatives of the inverse trig functions. So I was asked by somebody, I forget exactly who, but somebody asked me to make a video on the integrals of trig functions. So why not? Now the thing with the integrals is it's a little different than how the derivatives work, because with the derivatives you can just, you can write all the trig functions in terms of sine and cosine. So it's really easy to figure them out. You can just use product rule, quotient rule, chain rule, and you're done. Both integrals, it's not that easy. But luckily we have tools like u substitution and integration by parts to help us with these things. So I'm not going to go into too much depth of like how to do them because they're all, each case is very different than the next one. So it is what it is. But here I have the common derivatives, or the derivatives of all the 6 major trig functions. So basically, if you want to integrate any one of these, your answer is just that. So the integral of negative cosecant cotangent is just cosecant. The integral of secant squared is tangent, and so on and so forth. The thing that gets a little confusing is knowing, because like it's pretty easy to figure out, okay, if you're taking the derivative or integral of sine, you're going to have a cosine or negative cosine. But which one's which? Because you have the derivative of sine, derivative of cosine, integral of sine, integral of cosine, so it's really hard to sometimes keep track of like which one's going to have that negative sign. So what I like to do, because this is a common problem with a lot of people, what I like to do is just, I remember this one. This is the first thing I think of anytime I see derivative or integral of sine or cosine. I just think, okay, derivative of sine is cosine. So if I see the derivative of cosine, then I know, okay, well this one doesn't have the negative, so this one does. If I see the integral of cosine, I just think, okay, derivative of sine is cosine, so that's my answer right there. And if I'm taking the integral of negative sine, I think, okay, derivative of sine is cosine, so integral of negative sine must be positive cosine. So I just basically think derivative of sine is cosine, and then I go from there. So that's one trick that I like to use. I know a lot of people get mixed up with which ones should have the negatives or not. But yeah, that's a quick little way to do that. And as I said, you can use u substitution, integration by parts, and a lot of, especially in Calc 2, a lot of trig identities will help you. I'm not going to go into those, but I will go through one example. I want to go through the integral of tangent of x. So integral of tangent of x dx. So this kind of hopefully will give you some intuition about how to deal with these kinds of problems. So let's first rewrite tangent in terms of sine and cosine, because this is just going to be the integral of sine x over cosine x dx, right? So this is pretty easy. We can tackle it with a u substitution. We can say u equals cosine of x. Oops, sorry about that. U equals cosine of x. And the reason why we're doing cosine and not sine is because du will be, so derivative of cosine is negative sine, so negative sine of x dx, yep. And so du is going to be this negative sine of x dx. Sine of x dx. That's what we want, right? If we made u the top, the sine of x, there's no way we could write the cosine there. It just wouldn't work. So basically we can just replace what we have right now. So we have sine of x dx. That's going to be replaced by this negative du, because we can just move this negative to the other side. So we have this negative of the integral of, well, we have 1 over u du, so I'll just write du over u, okay? Sorry, it's a little, I prefer writing from this direction here. So we have du over u, which is just going to give us the natural log of the absolute value of u, which is cosine of x. And then plus c. And this is it. This is the integral of tangent of x, negative ln of the absolute value of cosine of x plus c. And I encourage you to try the integral of cotangent. It's a very similar process, slightly different with the u substitution, but pretty similar anyway. So yeah, so this is just an example I wanted to show, just a little quick video to talk about the integrals of trig functions. There will not be a video on the integrals of the inverse trig functions because a lot of those just don't work. Yeah, like the integral of inverse sine, if I recall correctly, it just doesn't have like an answer with like elementary functions. They are non-elementary, so like weird functions. So I'm not going to go through those. I'm sure there are a lot of other videos on YouTube that talk about those in greater depth. But yeah, so that's pretty much it for these little series of videos, and I hope you guys have a great rest of your day. Bye guys.